All right, so now we have some application problems with point slope form of a linear equation. So one of the things that's tough with these is identifying how to set it up and how to work. So a pointer before you get started is, as you read it, try to think about variables that can come out, things that changes, the context of the problem and what points in the problem actually change and need to be edited from one situation to another. Another component you can use would be to identify the question in the problem and talk about what that question is and what it's actually asking and how that question relates to the context of the problem. Find it. Okay, here we go. At Eagle Bay, it costs $12 per hour to rent a canoe. Nate and his friends rented a canoe for 4 hours and paid $68. Write and solve a linear equation to find the cost to rent the canoe for 7 hours. Okay, again, if you just read that, you probably got stuck in the blah blahs and you just saw 12 and you saw 4 and 68 and 7, and that's all you really retained. So you need to go back and read the question and break it down and understand what those numbers actually mean in their context and kind of rewrite it to simplify it so that you can understand it a little bit more. Okay, at Eagle Bay, blah, blah, it costs $12 per hour to rent a canoe. So like that's a significant statement. So it's not just this 12 that shows up, but it's per hour. Now, if you read that again, you might think, that's kind of a thing that changes, right? That's a variable, that's a unit. That's going to be one of our variables. One of our variables are going to come from that statement. We'll go back to that in a second, though. Nate and his friends rented a canoe for 4 hours. So Nate, 4 hours, and he paid $68. So I'm going to write that down on the side too. We have another scenario where we have information that has some units and has some reference to variables and things that happen in other parts of the problem. So for instance, in that statement that you just read, you have a statement 4 hours, but we also had another number that dealt with hours as well. We had $12 per hour. Okay, $12 per hour. That is represented twice in the problem. Very likely that's going to become one of our variables. Now we look at it, follow the conversation about Nate. Nate paid $68. When we look at that, $68, we've got a number, $12 per hour and 4 hours paid for $68. So now we dissected that first two sentences. Now let's look at the question or the prompt or the purpose of the statement of the problem, where we're going with it. Purpose statement, prompt, right? And solve a linear equation to find the cost to rent the canoe for 7 hours. Cost, there they are again, cost, hours. Boom, guess what our variables are? Cost, hours. They show up in each and every little component of this problem. Any relationship we've described is cost in hours. Purpose statement is cost in hours. So find it using the purpose statement and all the numbers and their units and their relationship to the situation. Read it, interpret it, go from there. Okay. Another thing is at the beginning of the chapter, we talked about slope being the rate of change, right? The rate of change of y over the rate of change of x. So the rate of change. If we have this statement, $12 per hour. Per in math means divide. And notice we have this scenario. We have 12. 12 is our value. We have dollars. Per hour would be dollars over the hours. So we have $12. $12 per hour. That's going to be our rate. And that almost gives us our fraction of 12 to 1, which is our rate of change, which also happens to be our slope. Slope being rate of change. Now we have another scenario where we have, if that's the rate of change too, we have which one's going to be our x, which one's going to be our y. Remember, rate of change, slope is y's over x's. So in this case, we have dollars over hours, which gives us dollars or the cost to be our y and the hours to be our x. Also, the amount of money you make is determined by the amount of hours you work. So if you're talking about like independent and dependent variables, like that's a thing. You've talked about that in science a bit, probably, and some other math. Hours would be your independent variable. Dollars would be the thing that happens as a result of the amount of hours renting. Okay, so again, now if we go back to where Nate is, Nate, 4 hours means X would be 4, and $68, that would be your Y, and we can turn around and make that into a point, 4 comma 68. So we have a scenario where we have our M and we have a point, and we can turn around, drop it in a point slope form, and go from there. That's what we're going to do. So to get the linear equation, okay, to find the cost to rent a canoe for 7 hours. So when we're writing the linear equation, we can use this point right here, and we can use this slope right here, and we can put it into point slope form. Y minus, X minus, set it up just like that. We have our X coordinate being 4, we have our Y coordinate being 68, and we have our slope being 12. After we write all of that in, we can turn around and we can distribute and solve it for y to get it in a slope-intercept form to clean it up a little bit. So we get y minus 68 equals 12x, and then we get 4 times 12, which is 48. And now we're going to keep solving it. We're going to add 68, add 68. We get y equals 12x plus 48, negative 48 plus 68 is going to be 20. So this winds up being our equation that we're going to use in this problem. So write and solve a linear equation. This becomes the linear equation that we have. Now we need to solve it to find the cost to rent a canoe for 7 hours. So this piece turns into 7 hours. So we have an x being 7. We're going to take that x and substitute it into our linear equation we just found for x, and we're going to solve it and figure out how much it's going to cost to rent a canoe for 7 hours. So we get 84 plus 20, which will be 104. We get y is 104, and that means our total cost to rent a canoe for 7 hours is $104. Good job, good job. Now let's go on to another problem. Pay attention. We'll see you in the next video for the next problem. Peace.